Let's go to page 249, and this is lesson 4.5. This lesson is to prove triangles congruent by ASA and AAS. Okay. So again, just like before, so same thing. If you look at this over here, okay, so here's your ASA. Notice the side is between the two A, so you got ASA. The side has to be between the two angles. Okay, so again, if two angles and the included side means the one in between the angles. So if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. Okay, so that's your ASA. Okay. Now, same thing over here. This is kind of came from here because this is an AAS. So if the side is not in between the angles, so there'll be AAS. If it's in between, then the side is between the angles. So AAS. Okay. Now the reason this is kind of came from here because from the earlier theorem, if the two angles of the triangles are congruent, then the third one will also congruent. So this will also congruent. See that? So it becomes ASA. Okay. So this is almost like the continuation of these. Okay. Because again, if two angles are congruent, then the third one would be congruent. And since if the third one is congruent, and then from here we can see it's ASA. See that? Okay. So again, this is kind of the additional step to that. Okay. So once you get those theorems, then you can use it to prove all the other the proofs. Okay. Okay. So let's go to page 250. Okay, identify congruent triangles. Okay, it says, can the triangles be proven congruent with the information given in the diagram? If so, state the postulates. Okay, so this one, see the marking? Okay, so remember what I said, right? They usually give you two congruents, then you have to, or two information, then you have to look for the third one. Okay. So over here, the triangles are congruent. See when the triangles, vertices point to each other, then you look for the vertical angles. Okay. So in this case, the vertical angles are congruent. Okay. The vertical angles are congruent. So that's your AAS. So this is yes. Okay. This one, notice that the three angles are congruent. So this is AAA. AAA is no good. Okay. The reason for that is because you can have a small triangle, okay, and you have a big triangle, and you can have, like this over here. See that? Okay. A good example, like if you have equilateral triangle, okay, you have an equilateral triangle, it's all 60 degrees, right? So based on coming up with a counter example, okay. So see that you can have a 60-degree equilateral triangle, the bigger ones, okay? So you can see that. So that's why there's no AAA, okay? Because this one doesn't work, okay? They are similar, but not congruent, okay? So this one is no good, okay? You need additional information to get it to be congruent. Okay, over here, this one, notice you got this angle congruent, this angle congruent, okay? Again, remember when you have two triangles butt against each other, you use a reflexive, okay? So this would be equal to itself. So you got ASA. Okay, so this one is yes. You can do the ASA. Okay, so now again, let's go to example 2. Prove the AAS congruent theorem. Okay, so they kind of give you the logic. Okay, so over here they give you angle A is congruent to angle D. So do the arc, see the marking. So as soon as you read through, make sure you do the marking right away. Okay, so you read that, you mark that. Angle C is congruent to angle F, so mark that. Okay, and also give you BC is congruent to that. Okay, so you want to prove these. So here's giving. Okay, and this is giving. So from here again, because if two angles are congruent, then the third one will also congruent. Okay, so third angle theorem. Okay, then once you do that, then then again, this is given, so now you're going to have the ASA. So right now, they haven't asked you to do the whole complete proof yet. This is kind of just like the planning, the flow chart, okay? So you can do more of that later on. Okay, so example 3 is a write a flow proof. It said in the diagram, okay, so CE is perpendicular to BD. So right away, you do that, okay? So right away, that you know that this is the right triangle. And angle CAB is congruent to CAD, okay? Write a flow proof show that triangle ABE, we want to show that these two are congruent, okay? Okay, so from here, the flow chart is, okay, first giving, right, angle CAB, so mark that. And so over here, BAE, so these are supplementary. So if they're supplementary to that, that means they will be congruent, okay? So the supplementary angles to the congruent angles are congruent, okay? So the congruent supplementary theorem. So again, these are supplement to that, this is supplement to that. So this one says that if they are supplementary to the congruent angles or the same angle, then they are congruent. So from here you can see that. Okay, then after that, remember when two triangles are butt against each other, you have to use a reflexive, yeah? See reflexive, right? So that's over here. So that's your, so again, if you have a right triangle, you can, in this case, it would be LA, the leg and the angle, LA. We're going to cover more of that later on, okay? But since you haven't learned that yet, so you can just use ASA, okay? So you can, so AE, reflexive, right? And also from your perpendicular, okay? That means these are 90 angles, and if there are 90 angles, the right angles are congruent. And from here, okay, that you have the ASA, okay? Okay, let's go to example 4. Okay, the fire towers. The forestry service uses fire tower lookouts to watch for forest fire. When a lookout spots a fire, they measure the angle of their view and radio a dispatcher. The dispatcher then uses angles to locate the fire. How many lookouts are needed to locate the fire? The answer is 2. Because all you need is to get this point over here, okay, you need the 2 lookouts and the distance between that, so you got ASA, okay, so answer is 2, okay, so you need 2, so you need to have any 2 lookout towers and the distance in between them to locate the fire, okay, so you can, once you, this one you measure the angle, and this one you measure the angle to that, the heading, right, so that means you got this angle, and you know the distance between the lookouts. So that's an S, so it'd be ASA. Okay, so you need to locate any location or any fire, you need to know, you have to get the observation information from at least 2, okay, two lookouts. Okay, so here's a concept summary. So here's all the theorems. So SSS, SAS, HL, the right angle only. Now notice because the right angle is already congruent, so that's why all you need is 2 more. So that's why you have 2 letters. You have ASA and AAS. Okay, these 2 are very similar because if you have these, right, again, from these, you can actually prove that the third angles are also congruent, and that becomes the ASA. Okay.